So now we're going to talk about type 1 and type 2 errors. And I'm going to talk to you with an analogy to help wrap your head around this. It's a pretty popular analogy for hypothesis testing. So you want to think of a hypothesis test like a courtroom trial. The null hypothesis is when you make the assumption that the person is innocent unless you find evidence otherwise. So the null hypothesis is the idea of the person being innocent. And then if we show evidence against that, then we're leaning towards the fact that the alternative hypothesis is true. So just like in court, we have four possible outcomes, right? We could have that the person is innocent and the jury finds him innocent. We have that the jury finds him guilty, but he's actually innocent. We could have that the person is guilty, but the jury finds him innocent, or the person is guilty and the jury finds him guilty. So with those four options, there are two correct options. The other two outcomes are errors, and that's what we call a type 1 and a type 2 error. So here in this table, we have it listed out. This is the decision of the jury or the decision of the hypothesis test. And then up here is the truth, okay? So if you make the decision that you do not reject the null hypothesis and you find out later that the null hypothesis is true, that is a correct decision. If your decision is to not reject the null hypothesis, but later you find out that the null hypothesis is false, that is what's called a type 2 error. Now looking at the second row, if our decision is to reject the null hypothesis, but you find out later that the null hypothesis is true, that's a type 1 error. And then the last outcome is that you reject the null hypothesis when you find out that the null hypothesis is false, and that is a correct decision. The last four examples, I have scenarios, and we're going to decide if it's a type 1 error, a type 2 error, or if it's a correct decision. And we're going to refer to this chart as needed. So for each of the scenarios, we're going to identify the claim, our HO. We're going to state the decision made. We're going to identify the true situation, and then classify the outcome as type 1, type 2, or a correct decision. So a company claims their batteries last 100 hours on average. Testing shows a mean of 98 hours with a p-value of 0.12. Using an alpha level of 0.05, you do not reject HO, but later you learn the true mean is indeed 100 hours. So let's identify the claim, our null hypothesis. The null hypothesis is that the battery average life is 100 hours. Now, the decision that was made was that we did not reject the null hypothesis. Later, we find out that the true mean is actually 100 hours. So, the null hypothesis is true. Now, since we did not reject the null hypothesis, and the null hypothesis is true, we would classify this as a correct decision. All right, let's look at the next example. Example 5 says, a manufacturer claims that their light bulbs have a 5% defective rate. Testing showed an 8% defective rate with a p-value of 0.03. Using a 0.05 level of significance, you reject HO. Later, you discover the true defect rate was actually 5%. So the claim is that we have a 5% defect rate. The decision that was made after the test was performed was that we reject the null hypothesis. Later, we discovered that the true defect rate was 5%. So we find out that HO is actually true. So if we reject HO when it's actually true, if we look up here at the chart, we reject HO when it's actually true. That's a type 1 error. So that's what we're going to classify this as. Okay, example 6 says, a restaurant claims their pizza delivery time averages 30 minutes. Test shows 33 minutes with a p-value of 0.06. Using an alpha level of 0.05, you do not reject the null hypothesis. Later, you learn that the true average is 35 minutes. So the claim is that the average delivery time is 30 minutes. We decide not to reject the null hypothesis. Later, we find out that the true average is 35 minutes. So the null hypothesis is false. Now, if we look up at the chart, if we do not reject HO, but HO is actually false, that is a type 2 error. So that's how we're going to classify this. Okay, last example. A coffee shop claims their coffee temperature is 170 degrees Fahrenheit. Testing shows 160 degrees Fahrenheit with a p-value of 0.01. Using an alpha of 0.05, you reject HO. Later, you confirm that the true temperature is 160 degrees Fahrenheit. So the claim is that the temperature is 170 degrees Fahrenheit. The decision that we made after testing was to reject the null hypothesis. Later, you find out that the true temperature is 160, which means the null hypothesis is false. So since we rejected HO when HO is false, this is considered a correct decision. So when you're working on these problems to identify type 1, type 2, or correct decision, leave your notes open to this chart so that you can refer to it until you get comfortable and familiar with all 4 outcomes.